Welcome to This Explainer. If you've been paying attention, you know May 2026 is going down as the exact moment AI definitively shifted from theoretical research into high-stakes, real-world deployment. I mean, we spent years watching models get bigger and benchmarks just get completely smashed. But suddenly, the conversation has changed. We're now looking at a fundamentally different landscape, where the focus isn't just on what these models can do in a lab, but how they actually operate in highly regulated, deeply consequential environments.
And this quote right here perfectly captures the tension. AI is moving from research to deployment faster than governance can follow. It really hits the nail on the head. Technology is moving at light speed, and our systems of oversight and trust are just scrambling to catch up. Three completely separate developments from this month sketch out this exact emerging pattern, showing us an industry pushing capabilities to the absolute edge, leaving governance frameworks gasping for air.
So here is our roadmap for today. First, the AI deployment era. Second, pre-release model reviews. Third, AI in the Pentagon. Fourth, AI meets cancer research. And finally, the bottleneck of trust.
Kicking things off with Section 1, the AI deployment era, or shipping faster than society can adapt.
Here's the core dichotomy driving the whole industry right now. It's technical capability versus operational trust. Developers have absolutely cracked the code on raw technical power, but the true challenge today, it's establishing operational trust. If you've shipped AI features recently, you already know exactly what I'm talking about. Building a model that can parse complex data and produce an accurate output is one thing, but getting a hospital, a government agency, or a major enterprise to stake their reputation and real-world outcomes on that output, well, that's an entirely separate and, honestly, a much harder problem to solve.
Moving right along to Section 2, pre-release model reviews regulating the frontier. Let's look at how the U.S. government is attempting to build that trust framework at the highest level. According to recent reporting, the Trump administration is actively considering an executive order featuring three major proposed actions. First, establishing a working group with tech executives and government officials. Second, creating a formal pre-release review process for new AI models. And third, superseding state-level AI regulations with a uniform national policy. This is structurally massive. By stepping in to review models before they ever reach the public, the government would introduce a major new constraint for developers, essentially real latency between a model finishing its training and actually being available via commercial API endpoints. Now, these White House talks, which reportedly included executives from Anthropic, Google, and OpenAI, didn't happen in a vacuum. They actually follow a highly publicized dispute that kicked off in February when Anthropic refused a request for unrestricted model access by the Pentagon. Later, Defense Secretary Pete Hegseth threatened to designate Anthropic as a supply chain risk. Following that, Anthropic filed a lawsuit, and recently a federal appeals court weighed in on the dispute. The whole timeline really highlights the incredible friction we're seeing right now between commercial AI boundaries and national security demands. And when we compare pre-release review frameworks globally, we see a fascinating alignment. The United States approach, operationalized by CASI, involves amended partnerships with Google, DeepMind, Microsoft, and xAI for pre- and post-deployment evaluation. This actually closely mirrors the existing United Kingdom model, where multiple government agencies are tasked with evaluating AI safety standards prior to public release. Tracking the UK's implementation gives us a pretty fantastic preview of what formal mandated US requirements might ultimately look like. Which brings us to Section 3, AI in the Pentagon, integrating commercial tech. Separate from the oversight discussions, the military is making some aggressive moves. The Pentagon just signed formal agreements with 7 highly diverse AI partners. We're talking OpenAI, Alphabet, NVIDIA, SpaceX, Microsoft, Amazon, and Reflection. You've got the massive hyperscalers right alongside smaller firms. And their stated goals are very clear: to streamline data analysis, elevate situational understanding, and augment warfighter decision-making in complex operational environments. They are pulling commercial AI directly into the military apparatus. And here is the absolute kicker. Classified deployments of commercial AI are now routine, not experimental. These are not pilot programs. They are formal agreements for use on classified infrastructure. High-security deployments are officially becoming the industry standard. This matters immensely because as soon as the military proves these systems can operate securely on classified networks, enterprise customers in finance, law, and healthcare are going to turn right around and demand the exact same security and access controls for their commercial tools. Let's shift gears a bit to Section 4, AI meets cancer research, pushing past theory.
We can observe the exact same deployment dynamic unfolding in clinical medicine. At the recent AACR 2026 conference, the conversation completely mirrored what we saw with the Pentagon. Looking at what's working, AI is successfully deployed right now in organoid models, digital pathology, and data analysis pipelines. But looking at what's hard, researchers are hitting major operational walls. Data integration across different institutions is incredibly difficult, and longitudinal patient tracking at scale remains a massive hurdle. Which is tough because AI systems desperately need that follow-up data to validate their predictions.
This leads us perfectly into Section 5, the bottleneck of trust, the engineering problem. In cancer research, the explicit bottleneck called out at the conference was clinician confidence. And that brings us to the definition of operational trust. It's the gap between an AI model producing an interesting output and a professional acting on it in a way that actually changes real-world outcomes. The capability is obviously there, but bridging that final mile to actionable medical or even military trust remains wide open. For developers building tools for regulated industries, trust is not an abstract feeling. It's a strict engineering problem. Earning a clinician or commander's confidence requires engineering trust through concrete features. You need model explainability so they know exactly how the AI arrived at its conclusion. You need clear audit trails. And you need seamless integration into existing clinical or operational workflows. These are no longer optional bells and whistles. They're the absolute baseline requirements for deployment. So what's the big takeaway from all this? From the White House looking to evaluate models pre-release, to the Pentagon weaving AI into classified networks, all the way to cancer labs revolutionizing pathology, the era of deployment is literally happening right now. The tools are undeniably ready, leaving us with one profound question to think about. Are our systems, our governments, and our human operators truly ready to trust them?